Lesson 8.2 is called trigonometric or polar form of complex numbers. So with the previous lesson, we looked at the complex numbers in the a plus br form. But now we're going to look at the trigonometric form where there's a magnitude and there's an angle involved. So we're going to handle the questions from our 8.2 homework. First question says, write the complex number in rectangular form. So we have this complex number defined as 14 times cosine of 30 plus I sine of 30. And this is the trigonometric or polar form of the complex number. We're going to convert it to a rectangular form. So we will copy the 14. And now we're going to plug in the value for cosine of 30. Cosine of 30 is root 3 over 2 plus I comes with me, but instead of sine 30, I will plug in 1/2. Now, when I multiply 14 by this fraction, it gives me 7 root 3. And then when I multiply this by I times 1/2, it will be 7i. I believe on the homework, this answer will not be accepted. They want you to enter your answer with 1 decimal places. I believe if this answer is not accepted, plug into the calculator. Calculator will give you the decimal corresponding of root 3, and then when you multiply it by 7, whatever the decimal becomes plus 7i, you can input this answer to the online method. Number 2 is a similar question. Again, we have the polar form of a complex number, and we want to convert it to the form of a plus br, which means we will copy the remaining. Instead of cosine of 270, I'm not using calculator. I'm thinking about these videos in my head and then giving you the corresponding numbers. Cosine of 270 is equal to 0. I times sine of 270 is equal to -1. So it's 20 times, this is 0, and then this is a -I. 0 times 20 is just a 0, and 20 times I is 20i. So on my MATLAB, I can just enter -20i since 0 doesn't have any meaning. Sometimes the polar form, instead of writing the polar form as cosine of 240 plus I sine of 240, they basically use this CIS, cosine I sine. If you see this cis, they are talking about the polar form. So now we're going to convert this expression to a rectangular form. So let's write what this means. We will have a 9 parentheses, first cosine of 240 plus I sine of 240. This is the given problem. Instead of writing it huge like this, they simply wrote CIS for this portion. Now, 9 times cosine of 240, again, the reference angle is 60 because 240 minus 80 is 60. So I'm going to write the same thing as cosine of 60. Cosine of 60 is 1/2, but 240 is located in the quadrant 3, and quadrant 3 cosine values are negative. So cosine of 240 is -1/2 plus I times cosine of 240, it's -3 over 2. Now, 9 times -1/2 is -9 over 2. And then minus, positive times negative is just minus. And when you multiply 9 by this, you will get 9 raised to 3 over 2 times r. Again, I'm leaving the answer in the exact form. If my MATLAB wants you to change these numbers to decimals, put this to the calculator and give them the decimal corresponding. For number 4, a very similar question. We're going to write it in rectangular form. I have 16 times. Now, cosine of -60. Cosine is an even function, so this is the exact same thing as cosine of 60 degrees. I'm just going to read out the problem first. But sine is an odd function, so this negative will affect the sign before the sine function, so this will change it to I sine 60. Now I am ready to plug in the values. 16 times cosine of 60 is 1/2, and then the sign is minus now. And sine of 60 is root 3 over 2. And then there's an I here. And I multiply 16 by 1/2, that's 8. And then I multiply 16 by this, that's 8i by 3 is the expected answer for number 4. For number 5, we're changing our object to 9. So we have the rectangular form given, and we need to write this complex number in the form of r times cosine of theta plus r sine of theta, where theta is any angle from 0 to 360 degrees. So we have the rectangular form, but we want to change it to a number times cosine of an angle plus r sine of an angle. First of all, how do I find the number that goes here? We're going to call it as z. Z will be calculated as a squared plus b squared. And then a is this number here, 3 root 3 to the second power, that I make theoretical. And then b is positive 3, so I make the 3 squared here. When I square 3 radical 3, that's a 27. And then 3 squared is 9. When I add them up and take the square root, this will be 6. So I'm going to need a 6 in the first box here. Now we have to find the angle. To find the angle, we need to find the tangent of the angle using the given complex number. So what I mean is, we have this equation, tangent of the angle we need will be always calculated as 3 over 3 radical 3. And then we can just simplify this. So this is 1 over root 3. So theta is equal to arc 10 of 1 over 3, 1 over radical 3. Without using a calculator, I know that this angle here is 30 degrees, because for 30 degrees, sine 30 is 1/2, cosine 30 is root 3 over 2. So tangent theta is equal to 1 over root 3 only for angle 30. And I have to just make sure that I am getting the angle in the correct quadrant. So the first number is positive, second number is positive. This is only possible in the first quadrant. So the angle is right. So we will need 6 times cosine of 30 degrees plus I sine of 30 degrees for this question. For example, here I know that, look, I have a -5, and then I have a positive 5. So the angle I have to give them must be in quadrant 2. First of all, we're going to find the z value by using -5 squared plus 5 squared and take the square root. This will be just 5 radical 2, so I will need the 5 radical 2 here. And then they want the radical, so this is 2. Now for tangent of theta, when I set up tangent of theta, I'm just setting up the tangent equation for the reference angle. Tangent of theta is b over a, so it's 5 over 5, which is just 1. So for the reference angle, this is 45 degrees. So for 45 degrees, tangent theta is 1. But I cannot put 45 here because the point I got by this complex number is in the second quadrant. In second quadrant, the same values as 45 degrees, we have 135 degrees. So the answer is 135 degrees for this question. I'm going to let you explore 7 and 8 using this strategy. And then it might be very helpful to plug in the complex number given to you. So don't forget that this is the real axis. This is the imaginary axis. So, for example, for question 8, if you have 2i, this is your complex number. Even here, you will see that the angle you will need is a 90 degree. But 2i means 0 plus 2i. So for z, you will need 0 squared plus 2 squared, which is the same thing as 2. So its magnitude will be just 2. So the number goes here is 2. Now for the angle, tangent of theta is equal to 2 over 0, which is undefined. So the only angle whose tangent value is undefined in quadrant 1 is 90 degrees. So therefore you will need a 90 here and 90 here if you have this 2i as a complex number. All these questions are going to help you to understand this concept better. When you have just a 10 as a complex number, this is your 10. So you see here that the angle associated with this complex number is just a 0. So you can plug in the values here without applying the formulas. And 8i is very similar to what we did on the first question for 2i. Good luck with page 8.2.